Hey there and welcome back to the Code Wrinkles channel for a brand new video. This one, I guess it will be a very simple one, but I would say it's very important because it's about a C# feature that in my opinion is very underused and overseen in a lot of scenarios where actually it might be very useful. And we'll talk about params in C#, how we can use them, what it actually is, and in which scenarios this might be useful. And in order to also have a practical reference to it, we will start from a very basic console application example, just to understand how params work and what are the situations in which params might actually help us a lot. But then we'll go over to two examples that are, I would say, from real applications in which you could use them, or at least try to use them if you understand exactly how that works, and it would actually make your life easier as a developer. So let's start here from this very basic example that we have in a console application. And I have already set this up for you. Here we have just a regular console application, and here we just write something to the console. We have a student class, and we have there a method which is calculate grade average. Of course, here I have a typo, but okay, that's not important. So let's take a look here at our student class, where we have this static method. Now let's calculate grading average, and we have here two params, like two incoming parameters to this method, like it would be an int for x and an int for y. And then, of course, we calculate the average based on the fact that we know that we have two parameters here, and we actually add them, so get their sum, and then we divide them, and we will also make sure that we cast this to a double so that we don't use any precision on this type of thing. So if we run the application, as you might probably see here, of course it's 9.5 because this is the average for those values that we have provided right now here in our program app. Cool. So before you go on to comment that, okay, you would probably not calculate the grading average in the student class, I totally agree with that. You would probably have that in a separate domain service that is responsible for doing a lot of calculations or different type of similar stuff. But here we just want to focus on one thing, and for convenience we have just placed this method here in the student class to actually have also a conceptual understanding about what we actually try to achieve here. Now, with this approach, we have actually one very big problem, because right now we have this method, and yeah, we just calculate the average. But this method makes also an assumption that we will always have actually two subjects for which we will have a grade, and for which, of course, we would have to calculate the average. Now, I would assume that that would not be true in most of the cases. Like, problem is that usually when you work with this type of stuff, the number of the incoming parameters might actually vary from student to student, because there is one student that might have 3 subjects. There might be another student that took part and made exams for 5 subjects, or for 8 subjects, or for even 1 subject. So what do you do then? So if you say that, okay, we need to calculate the average, but it might be that students also participate or take exams in 3 subjects, okay, then the first thing that I would do, or I would think about doing as a developer, is, okay, cool, let's actually make an overload for that, and let's do it like that. So it would be then a very simple. Here we just add this z to the plus, and here we just have to divide this by 3, because right now we have 3 params. And then we go here, okay, we have 9, and let's also give here a 7, and the application still works. So the working of the application is not affected by this, everything is still okay. And we also get the result, and it would be this one, which is okay. Now, once again, the problem is that there might be students that need to, or that participated in 5 subjects. Now, in that case, we would go on and create a new overload that takes actually 5 integers and then calculates this type of integer. And I guess you imagine you could go on and on and on. The idea is that for this type of logic here, in our case, for our calculator here, is that the number of the parameters is actually variable. So it's not that you have either 2 or 3 and that's it. It's totally variable. It could be 2, it could be 3, it could be 4, it could be 5, it could be 6, 7, 8, or maybe even 9. So it's crazy to just create then 5, 6, 7, or 8 overloads actually for the same method just to do that. So here is where C# params come into place, and they are very, very powerful and useful, because the idea is that instead of creating a lot of overloads for this same type of logic, you could have just one method that takes in a param array and then does the logic that needs to be done. And then no matter if you have then 3 subjects or 5 subjects or 10 subjects, the method would still work. Now let's see how this actually works. It's very simple, because instead of having these incoming parameters int x and int y, what we'll have instead is we'll use the keyword params. That's very, very important. So we use the keyword params, and then we say, okay, what type of params do we actually want to have in this method? And we keep on with integers. So we say that we actually want an int array, and we call this grades. Cool. Now the idea is, let's implement a logic. So right now we know that we will have an array of integers, so the logic will be a little bit different. So we'll have some, let's make it 0, and we will need a for each here, and for each var, let's call this grade. In grades, we just add the sum plus equals grade, but not the string reader. No, that's not what I want. This is what I want. Cool. And then when we are ready with that, we just can say here return. Once again, we want to make sure that we don't lose any precision, so we cast this to a double. And then what we do here is, yeah, we take the sum, and the only thing is that in this case we divide it by grades.length, and that's it. And actually we don't need to change anything in our methods. Let's first run the application once again to see that it still works and it still gives the same result. And yeah, it's 8.6. So we see that that is correct. Now let's go back here to this program class. And if we say, okay, let's remove this, we want to have two grades once again. So, okay, let's run that, and it will still work and it will give the same result. Now, let's say maybe for this other student, we have 5, and maybe he has another 10, and then maybe he has a 6, and then maybe he has a 7, okay? And now we have 1, 2, 3, 4, 5 different strings that we actually pass into this method. And you see that if we run that, it still works. And you might find this a little bit strange, but that's actually how params work in C#. And here the average is 8.4. Now, the idea is that when you specify here a params as an array of a certain type as an incoming parameter to a method, what does this actually mean is that the consumers of that method, they don't really need to provide an array by themselves, but they just can enumerate different values of the same type. And C# will automatically place all these numbers that we provide here in this array of integers so that we can iterate through the array and work with that. And you can see that this gives you a lot of flexibility in your code, and it allows you to actually have the option to have a variable number of incoming parameters to your method, which is very important in a lot of scenarios where this might be the case. So instead of just creating tons of overloads, just take in a params object and everything should be fine with that. Cool. So that is really the very, very basic example. So let's see how we could apply this in practice in 2 different examples of applications that we might have. And let's go here first to this one that we have already worked on when we created the video on structured logging in ASP.NET Core. And by the way, you will find a link to that video in the description of this one and in a card on the screen right now. And you might also want to check that out if you want to get started and better understand why actually structured logging is very important for real applications, because it really allows you to make your logs very powerful, that they could be queryable, searchable, filtered in logging aggregating systems, which are very, very important. So that's really a very important part, and I would strongly encourage you to look into that if you are not 100% aware of what structured logging is and why that is actually useful. And here, what we see is that as part of this structured logging, what we have here is that here we log in information. And the way that we do this when structured logging, we just provide here a string, and we provide a placeholder for different values that we actually want to add to our string once when it is actually logged and written to the different logging sinks that we might have configured here in our application. Now, what we do here is that by default, what we have done is we have creating a new object array, and we have provided here actually strings or values for all these placeholders that we have here in the string. And the order here is very important because we have to actually do this exactly in the same order. So it means that this name of weather forecast controller, which is actually a string, will belong or will be placed here. This name for the get method will be placed here in the action. And then the datetime now will be passed in here to this datetype now. And what we have done here, we have used an object array for that, because that's actually how you could do that. But if we hover our mouse over this log information, what we see here is that, okay, this is an extension method on the iLogger. It takes in the message, which is structured message template. But if we take a look, this object array here, args, it's actually a params array. Now, what does this actually mean is that we can simply get rid of everything here, that what we have like this new array, because that's actually not needed anymore. So instead, we can just have this here. Probably a little bit of reformatting is needed, and we can see that the application still works. So you see that here we have the message, and then instead of creating a new object array, we just provide all the parameters in the order that they need to actually be replaced in the string template that we have provided previously. So no object array needed anymore. And of course, we could do exactly the same thing here. So let's remove that, and let's also remove that. That's not needed. And instead here we can just provide the object itself. You see, we don't have any errors, and everything will work fine. And of course, this is what we could also implement here. We don't really need this one, and we also don't need this one. So we can get rid here of this new object array, and our code is already much more cleaner than that. And of course, we could go on through all the places where we use the logger. And since this log information extension accepts a param of objects, we can simply just provide the objects that we want to our method, in this case to log information. So no need to actually create an array for that. We can just pass in all the information that we want to have in our logs. So that would be the first, I would say, practical example where this is actually useful. Let's now go over to a second practical example where this might be useful. And here we are looking at our application that we are developing during our live streams, which is a CWK Socials, I would say, social network API from scratch. We have started it with clean architecture, CQRS, mediator, and some fun stuff. But we have really created it like a real application, like a real production-ready application, having also API versioning and having a lot of filters. So really, we have created this application like I would do that for a real customer. So I would consider that as a real application. Now, as part of that real application, there is one thing that we are working a lot with GUIDs for identifiers for our entities that we also write in the database. Now, this means that whenever we actually get some requests that also provide some identifiers in the route, like get something by ID, it will always be a GUID. So what we want to do is actually to check when the request comes in, before even the controller action is executed, we want to really check if that is actually parsable to a GUID, because if it is not, then what we do here, we already set a result which indicate that we have an API error, so we cannot handle that request. It would return a bad request. Now, the idea is that what we have done in the beginning, so first of all, we had very simple endpoints like get a post by ID, for instance. So in that case, for validation, we use this as an attribute, and we say here, okay, string key, and everything worked fine until we actually got to some more nested resources in different controllers, where we might have maybe, I don't know, maybe a user profile ID as a routing param, but also maybe a post ID. So in that case, we would actually have to verify two GUIDs or that they are really parsable to GUID, so that that we can really work with the data. So what we have done here, of course, is once again probably due to the fact that it comes natural. Okay, let's have one more constructor here, and here, okay, instead of accepting only one key, we accept here two different keys, and we have a list of key here as a field, and we just add the things to that. Now, of course, this adds a lot of overhead, because if we want to have, or if we have endpoints at a certain point that have 3 GUIDs as routing params, we would have to create a new constructor and start everything from scratch. So that's of course not optimal, and that's really a very clear case or scenario where we could use params, because we can refactor our code very simply. And instead of requiring here a key as a string, we can say here params string array, and sorry, it should be an array, of course, so it's a string array, and we'll call that keys. Okay, and now of course I would have to actually make this as a read-only array of string, but to actually not break all the other parts of the applications right now, I won't do that. I just want to show you how params work and how params can be applied in this case. Now, the only thing here is that instead of adding something to the keys, we will say that keys equals, and we'll say here keys and toList. So let's take the array and make it a list, and everything should still work. And right now we see that here we have one usage for this constructor, which is, if we go here in this controller, where we see that, okay, we have this one and this one. Cool. Now let's go back here and just remove this constructor here, because we don't need that anymore. And what is changed here, we still don't have any errors, but what has changed here is that we actually, you see, we have these param keys. So actually everything works still the same, but we have made our code a lot more cleaner. Of course, we don't need the keys here. And right now, no matter how many GUIDs in your routes you might have to validate, you can just add all the strings that kind of like represent the keys for where to find those GUIDs. You can just place them in the constructor. And since we have used here a params of string array, then C# will automatically actually take all the different values that we have here, maybe 1 value, 2 values, 3 values, and will create a string array based on that. So we can just use that string array and everything will work. So that's basically it. That's how easy it is to work with params, and this is how powerful params are in C#, because they allow us to have a much cleaner code, because we don't need to overload constructors anymore in a lot of scenarios, and we don't have to overload methods anymore in a lot of scenarios, because really in a lot of circumstances where we actually do this type of overload for constructor or methods, we actually do that because maybe we have a number of incoming parameters to them. So if the only thing that is variable is the number of the parameters, well, then we can easily just write only one method or only one constructor, take in a params, and then everything will be fine and will still work greatly, because all the consumers can do, they don't really need to provide a ready-made array. They can just provide us with values, and as long as those values are of the same type, C# will automatically take them and place them in this array of strings in this case. If you enjoyed this video and you find this content useful, please make sure to share that with others. Sharing is caring, and I would totally appreciate that. Also, if you have any questions or ideas or anything that you want to get in touch with, don't be shy and feel free to use the comment section of this video. I would be more than happy to get a discussion going and have a chat there. And yeah, once again, thank you very much for watching, and until the next time, I wish you the very best.